We're still in unit 6.5, and what we have here is that they give you g be a function with first derivative given by this accumulation function now. So now we have it where the derivative, they're saying g prime of x is equal to this integral from 0 to x of e to the negative t squared dt. Which of the following must be true on this interval 0 to 2, not including 0 and 2. So now we have to go through each one of these, right? What is it asking? It's saying g is increasing and g is concave up, g is increasing, g is concave down, so forth. All these things. Well, what determines these things? I wrote the rules that are going to help us out. So here's the rules. If the derivative of g is positive, then g is increasing there, okay? And that's going to help us out a lot. And if the derivative were negative, right, so the other statement to this is that if g prime of x is less than 0, is negative, then g would be decreasing, right? So that could help us out as well. So we could maybe put that rule also if you want. If g prime of x is less than 0, then g is decreasing. And similarly, a similar rule applies to this over here, that if the second derivative is greater than 0, then g is concave up, and if the second derivative is negative, then g is concave down. So let's somehow use these 4 facts to answer this question here, because it's talking about increasing in concavity, and these are the things that we're going to use here. So if you want the other one, the last one, which is just, very intuitive from this first one, that if the second derivative is less than 0, then g is concave down. And I'll draw what concave down even looks like. That's concave down, this is concave up, right? Okay. So now, okay, let's see. So let's see what we have here. They're giving you a function for g prime of x, and the question is I got to do some analysis on this integral. There's no way about it, and it looks like an ugly thing here, but what's important is that you have some idea that basically that integrand, that function on the inside, this is called the integrand, this here, is never negative, and it's definitely not negative between 0 and 2. So it's going to look something like this, right? That's 1 over e to the t squared, right? So if this is t, right, 1 over e to the t squared looks something like this, okay? And I mean, that's, obviously very high. And what you need to kind of just be able to envision that if I take some x here and I integrate, right, I'll be okay. Or wait, does it look like that? Oh, wait. What does it look like? So when t is 0, I get 1. So it's 1 over here. And it doesn't spike off to infinity as you get closer and closer. What does it spike? It spikes down, right? Yeah, it spikes down like this. That's what it looks like. Good. Okay, that's even better. That's a rough sketch of what's happening here, and that's all I need to know, because if I'm integrating from 0 to x, this integral is for sure positive. It doesn't matter what x I choose. So basically what this says is that g prime of x is always positive. And then that means that g is always increasing. So it is increasing, especially on 0 to 2. So, whatever, 0 to 2, it doesn't matter. The integral will be positive. I choose any x, right? The integral will be positive for any x that I have. Because look, right, like g prime of 1. For example, just to illustrate. Here's what it looks like again, rough sketch. Here's 1, let's say, and it goes like this, right? So g of 1, here's 1, right? It's just this integral, which is of course a positive integral, but it doesn't matter what I pick. G prime of a half, right, would be still positive. It would always be positive for any value that I plug in here. So g prime of x is always positive. Okay, that integral here, right? That integral is always going to be positive. Now, that tells me that it's between a or b. And then the next thing now I want to look at is I want to look at g double prime of x. And for here, I'm going to use the fundamental theorem, which tells me that the derivative of this, right, is just if I plugged in x for t here. So I'm going to get that the second derivative is e to the negative x squared. And that's the same thing as 1 over e to the x squared. And similarly, if you look at this here, this is a crazier function than what I drew here, perhaps, but it's something like that. It's going to spike down. It's always positive. I mean, that's what's key, is noticing that this is always positive for both of these conclusions. And this is always positive. And since it's always positive, the second derivative is positive. And you need to check that between 0 to 2, this value is for sure positive. You're never going to get a negative value. So it might be small, and it might be getting smaller as you go out towards 2, but it's never going to be negative, which means that the second derivative is positive, it's greater than 0, therefore g is concave up. And your choice A is the correct answer.